Welcome back, everybody. Today we are going to be talking about measuring angles using degrees and radians. The definition of the measure of an angle is how many degrees lie between the initial and the terminal sides of that angle. So let's get a couple of examples going here, and these are all very much review for you. Let's just draw 4 angles, and of course we have some labels on them, and let's talk about each one. The first one is an acute angle, and the definition of acute angle is an angle that is less than 90 degrees. Now we're going to say it lies between, this is theta, theta lies between 0 and 90. Cannot be equal to 0, cannot be equal to 90. The next one is a right angle, and a right angle is exactly 90 degrees. The next one is, alpha here is an obtuse angle, and an obtuse angle lies between 90 and 180, but it can't be 90 and it can't be 180. The last one is a straight angle, which is also just a line. We want to learn how to measure angles in radians. Now, that's kind of like if I have a length and I want to measure it in inches, and I can also measure it in feet. Up to now, you've probably only heard about measuring angles in degrees, but now we're going to go on to measure angles in radians. So to do that, here's the example. Inches to feet, feet to yards, or Roman numerals, our Arabic numeral system to Roman numerals. They're equal. They're the same thing. I can say 10 equals X, or 8 equals VIII. It's the same thing, and it's just a conversion from one thing to another. This is a long, rather tedious definition, but we're going to go through it piece by piece. This is the formal definition of what a radian is. 1 radian is the measure of a central angle of a circle that intercepts an arc equal in length to the radius of the circle. Yikes, that is a mouthful. But you should recognize the central angle. That's the angle that is formed, whose vertex is right smack in the center of the circle. And you know what an arc is, and you know what a radius is. So let's kind of try to put these together a little bit. So here we have our circle of radius r. What the length of a radian is going to be, if I take the length of the radius and I kind of stretch it along, or I bend it along the circle, that is going to be 1 radian. Okay? So the radian measure of the central angle is what we're looking for. And there's a formula for that. The formula is the length of the arc divided by the radius. So it's going to be the length of the arc on the circle divided by whatever the radius is. Let's do some examples. Okay, we have a circle, and we have a radius of 6 inches, and we have an arc that is 15 inches long. And we want to find what is the radian measure of theta in this circle. Okay, well, we know that it's going to be the intercepted arc divided by r, and the intercepted arc is going to be lowercase s. I do a script s so it doesn't look like a 5, divided by r, the radius. So all we have to do is kind of plug and chug here. The intercepted arc is 15, and the radius is 6, so that would make this 2.5 radians. Let's do another one. Now I have a circle whose radius is 3 and whose intercepted arc is 4, and I want to find out what theta is here. So once again, I have my theta equals the intercepted arc over r, which would be 4 over 3, which is 1.3 radians. And notice that I do use the word radians with it. 2 things you need to remember. Make sure that r, the radius, and s, the arc length, are in the same units. If one is in feet and one is in inches, you're going to have to change them both to feet or both to inches. Okay? And also, this formula is always in radians. You don't use this to find the degree measure. If you're given degree measure, you have to first change it to radian measure. Now I want to know, what is the relationship between degrees and radians? Well, we know what the relationship is between inches and feet, and we know how to convert back and forth. So let's see what we can do with our radian and degree measure. First of all, we know that a circle has 360 degrees in it. I'm going to put that on this little chart. But what would that be in radians? Well, we're going to go back to our formula. Theta is the arc length over the radius. And in this case, we know that the arc length is the full circle. And we're not talking degrees now, we're talking a length. And the length around the circle is called the circumference. So it's going to be the circumference divided by r. Well, what is the circumference of a circle? Well, it's pi times diameter, or 2 times pi times r. And if we divide that by r, lo and behold, the r's cancel and we have 2 pi. So 360 degrees is 2 pi radians. And if we divide everything by 2, then we have 180 degrees is pi radians. So this gives us a way to convert from degrees to radians and radians to degrees. The little formulas are to go from degrees to radians, take the degree amount and multiply it times pi over 180. To go the other way, to go from radians to degrees, you're going to take your radians and divide by 180 divided by pi, multiply by 180 divided by pi. So this is something that you need to write down and remember. Okay, let's do a couple of examples. First of all, let's change pi over 4 radians to degrees. Well, we're going to start with our pi over 4 times 180 over pi. And look at the pi's cancel, and the 4 and the 180 cancels, and we get 45 degrees. Let's erase some of this up here so we have a little more room to work, and let's do another one. Let's change 30 degrees to radians. Okay, we're going to go from degrees to radians, so we're going to put our degrees times 180 times pi over 180, and we have 30 and 180 cancel, so we have pi over 6 radians. So there you have it. Go ahead and work your example problems, and let's see if we can kick it up some. Thanks.